The purpose of these two formulas is to calculate the heat transfer during a phase change, specifically during a phase change. And there's two different ones just depending on which phase change that you're referring to. So they're very similar. Q is our heat in joules, M is our mass in grams, and both of those formulas have those. The only thing that's different is this H value. We have HF and HV, and those stand for heat of fusion and heat of vaporization. So the reason we have two different H values is depending on the phase changes that are happening. So the heat of fusion is used for melting and freezing, because the heat of fusion is defined as the energy required to melt a substance or the energy released when freezing a substance. And the heat of vaporization is the energy required to vaporize a substance or the energy released when condensing a substance. So another way to think about it is this first one is used whenever you're going between a solid and a liquid, or the opposite direction. And this one is used when you're going from a liquid to a gas, or the opposite direction. For the most part, all that we need to worry about is doing these calculations for water. So we have two known values for H with water. We have the HF for water, which is 334 joules per gram, and the HV per water, which is 2,260 joules per gram. And these can both be found in your reference packet under thermodynamic constants. We have the heat of fusion of water and the heat of vaporization of water. Let's look at a couple example problems. These are pretty easy. All you need to do is, as always, figure out what information we are given and plug them into the formula. So this one says, how much energy is released when 10 grams of water freezes? So since this is freezing, that means we are going from a liquid to a solid. So that's why we're going to use our heat of fusion formula to figure this out. So we have Q is equal to mHF. Q is our energy. That's what we're going to be looking for. So I'm going to leave that as Q. M is our mass, which in this case is 10 grams. And HF is our heat of fusion. Again, this is water, so we are going to use the heat of fusion for water, which is 334 joules per gram. So all we have to do is work this out to solve for Q. So Q is going to be 10 times 334. Those gram units cancel out, so that leaves us with 3,340 joules. Over here we have a very similar one. It says how much energy is needed to boil 10 grams of water. So since we're boiling, that is going to be going from a liquid to a gas, which means we are going to use the heat of vaporization. Remember, vaporization is basically the same thing as evaporation or boiling, just another fancy word for it. So we're going to use Q equals mHV. So how much energy? Energy is Q, same thing as heat. Okay, Q is what we're solving for, is needed to boil 10 grams is our mass again of water. So again, we're going to need the HV for water, not the HF, the HV, which is 2,260 joules per gram. So just like before, we're just going to multiply those numbers to get our answer. So we get 22,600, and those grams cancel out, so we're left with joules.